Hello, everybody, for another Kubefirst Live. Super excited this week. I mean, you know myself now. I'm always excited for any live stream that we're doing, but like there is a bigger notch for me when we have a guest because as much as I love John, just John and I on the live stream can be a little more boring. So no, that's not true. It's still good.
No,
Anyway.
Kubefirst is just better with a friend, isn't it?
It is always better with a friend, and who's better to talk about specific technology than the people who created it. So super excited today. We have Andy Suderman with us, CTO at Fairwinds. How is life, Andy?
Oh, life is good. Life is good. Colorado, weather is always good here when it's not snowing. So
I know the feeling a little bit coming from Canada. Winter was a little bit weird here. And John, how was life?
Life is good, Fred. It's been a crazy busy week, month, year. But excited to get into Goldilocks a little bit. Really happy to have you on the show today, Andy. And it's one of these rare topics that is in front of everybody's face and nobody wants to talk about. And so it's nice to have a voice of authority on the topic, talking with us today. And excited to get into it. We've got some cool integrations with what we're going to talk about with the GitOps catalog. So I think we've just got a nice, well-rounded show today.
Yeah, it's going to be fun. And just before we jump right to the topic, Jared, our man, saying welcome to the show, Andy. Jared is is one of the co-founders. I was going to say he's part of Kubefirst. Like he's more than part of Kubefirst. He's one of the
beating heart. The beating heart of engineering.
He is Kubefirst, and he's just annoying us with the beautiful day today here in Denver. It's sunny in Montreal, but like it's really, really cold. And you know what? We could not do a live stream without having Patrick Labs watching us. Patrick, you need something. We need to have like I don't know. I don't know if it's the thing in the States, but like here when you were in elementary school and like you answer correctly, the teacher, you get like a star sticker, a smiley face sticker. So we need those kind of like stickers that we can give like to people like attending the shows and always being there. So amazing to have you as always, Patrick. So thanks everyone for joining us. And without further ado, I think it's the time to learn a little more. What is it about getting your resources requests just right? Because I love it's a catchy phrase, but now I need to know what does that mean.
Yeah, that's a great question. Naming things is always hard, and I don't remember whose idea it was. I think it might have been my wife's idea to name it Goldilocks. It's a really good idea, but
it's a great brand.
Yeah, it's been one of my favorite names. I think it might be the one that kicked off sort of our space theme for naming all of our tools, actually, because we've got Pluto, we've got Polaris. So we just kind of, instead of going with the nautical theme, because we felt it had been overdone even 5 years ago, we were like, we're going to go with the space theme. We'll just pick a new theme. But anyway, resource requests and limits. I like to talk about the history of Goldilocks because it goes way back. I've been with this company for 6 years. I've been doing Kubernetes for 7 or 8 now. I think, all the way back to like Kube 1.4, I think. So if you can remember from that far back. But I joined Reactive Ops at the time, which is now Fairwinds. And I was running Kubernetes clusters for our customers. And we would consistently tell them, you need to set your resource requests and limits because that's how the scheduler knows where to put your pods and it knows how to scale up and scale down. And it prevents bad things from happening by setting limits. And our customers would come back to us and they'd say, well, what do I set them to? And that's a very reasonable question. We were like, well, all right, let's go into Datadog and we'll look at the last month and we'll, do some eyeballing at some graphs and give you an idea. And I was like, man, we do this process like every week for a different customer. There has to be a better way. And at the time, I also wanted to learn how to write Go because I had only really written Python before that. And so I was like, I need a project because that's how I learn. And so I was like, well, why don't we do something with resource requests and limits? I went looking around. I'm like, I really don't want to write a recommendation engine. That sounds like way too much work. And so I stumbled on the VPA project. sitting right next to the cluster autoscaler in the Kubernetes autoscaler repo. And I was like, well, they've got a recommendation engine. This is great. Well, what does this do for me? So I spun up VPA, the vertical pod autoscaler, if I didn't say that already. And it's like, great, it's giving me recommendations, but these are kind of hard to consume. Like I've got to create a VPA object for every one of my deployments or stateful sets. I've got to go inspect the status of that object in order to get the recommendation. I don't really want to run VPA in automatic mode where it's automatically setting the resource requests and limits, because that doesn't play well with HPA. And we're currently telling all of our customers to use the horizontal pod autoscaler, and they're all scaling on CPU because it's the easiest way to do it.
Yep.
And so I was like, well, we got to be able to consume these recommendations. And so I was like, well, let's write a controller that will create all the VPAs for all the deployments in the cluster. We'll set them in off mode, because then we can run in conjunction with HPA, but we still get the recommendations. And then let's build a dashboard to visualize that, so we can show all of our customers, hey, just go to this dashboard. This will tell you of some baseline to set your resource requests and limits to that's based on the recommendations from VPA. And so that's how Goldilocks was born. And at its core, it's really a simple project. It's, create some VPAs, grab the status object out of those VPAs and put it in a dashboard. That's really all it is. Dig
it. Let's talk for a quick second just about requests and limits in general. Typically when you're setting up your first deployment YAML, you get to that section where it's time to set your requests and limits. A lot of times, maybe you're using a default Helm chart and they'll have those values set up for you, but they'll be commented out, and maybe you just have never paid attention to them ever since, and you just don't have any requests and limits set. Can you describe a little bit about if you don't set requests and limits, what happens, and then when you set a request, how that changes things, and when you set a limit, how that changes things?
Yeah, definitely. So when you go to schedule a pod in Kubernetes, when the scheduler sees that you want a new pod and it wants to put it somewhere, it looks at the requests and limits, or it actually looks at the requests. Let's just start with requests. Mm-hmm. It says request 100 millicores and, say 100 megs of RAM. Let's just make up numbers here, right? And so what it does is it looks at all of the nodes available, what's already scheduled on those nodes, and it looks for a place to put that pod where it will fit with all of the other requests on that node. So if you don't have any requests at all, your pod gets placed into what we call best effort quality of service class, which means it's just going to throw the pod somewhere, right? It's just going to put it somewhere that has some amount of space available. I think it has to have at least some available, but it doesn't really know what to look for. So the scheduler just throws your pod out there and says, hopefully it'll run, right?
Right.
When we put a request in, it says, okay, you need 100 millicores. I see that this node has 12 other workloads scheduled on it, but there's 100 millicores of space left in all of those requests. So I can put that there. And it needs 100 megs of RAM, and it's got that available. Great, I'm going to put it there. Now you can think as you do more and more of this, we can bin pack, and this is how we trigger the cluster autoscaler, because if there's no space available for your request, it'll trigger a scale up with the cluster autoscaler, or if you're using a different cluster autoscaler like Carpenter or something like that, it will trigger it. And so the request is super important. If you don't set anything else, just set your requests to something reasonable, because then the scheduler can make an informed decision about where to put that.
Okay.
So that's requests. And then we get into limits. And limits are a little bit more complicated because they're different based on whether it's CPU or memory. If you set let's start with memory limits, because these are kind of the easiest ones. If you set a memory limit of 100 megs, then if you exceed that, then your pod will get killed. Out of memory killed, OM killed. We've probably all seen this message somewhere in Kubernetes. It happens pretty frequently, especially if you're setting memory limits. And so it'll just kill your pod, and then your pod will come back up and it'll start to consume more memory, and then eventually it'll get killed again. And this is a nice thing in Kubernetes, because if you have a memory leak in your application that's nice and slow, it'll just get killed off every 30 days or whatever, and then it'll come back and we don't have to worry about it. So it kind of erases the problem of memory leaks. You should still go fix your memory leaks. But anyway, it sort of prevents the pod from affecting other pods around it by consuming too much memory. Now, CPU limits are a whole topic that there's many well-quoted articles on the internet about CPU limits, why you should not set them, all of these things. But at the end of the day, CPU limits cause CPU throttling when you start to consume more CPU. And this can drastically impact the performance of your application if you're being throttled. And I don't want to get into all the details of how that works because it's very complicated. I don't fully understand all of it. The real problem is that we define it in segments of a core, but you can't divide a core. And so what we're really talking about is CPU time that's available.
Mm-hmm.
And so things get really weird when you start talking about time in quantities like we do. And so throttling is a very complex topic. There are a lot of good reasons to set CPU limits. I still advocate setting them. I do think there are situations where they should be not set. And there are applications that perform better when you don't set them. And so do a little research, find out whether you think CPU limits are right for you or not. One of the biggest arguments that I've seen, and that sort of the next topic to talk about when you talk about CPU requests and limits, is that quality of service that I mentioned.
Mm-hmm.
When you don't set any requests or limits, you get put into best effort, right? Quality of service. So maybe we can run your pod, maybe we can't. The second level is when you set your requests lower than your limits. So you say you request 100 megs and you set your limit to 200 megs. That's what we call burstable QoS class. And that means you can, you're going to get scheduled based on that 100 meg request. Your HPA, if you're scaling on that metric, is going to scale, like your target is going to be a percentage of that request. So requests affect that. And then you'll only get killed if you go up to 200. Now, if you set them the same, so you set your CPU request equal to your limit, you get put into, I just blanked the name. Guaranteed QoS
Guaranteed,
class.
yeah.
Yes, thank you. Guaranteed QoS class. And this has multiple effects on the cluster. So it's saying that we're going to try to guarantee you these requests. But also what that does is it gives the pod a higher priority for eviction when things need to get evicted. So when a node becomes overwhelmed, either CPU, well, not CPU causes throttling, but when memory gets overwhelmed, things will start getting killed whether they've hit their limits or not, right? And in order to clear out space on that node, and that happens in a specific order based on the priority of the pod.
Interesting.
And so when you're in guaranteed QoS class, you get a higher priority than pods that are in the burstable QoS class. And so it's a nice way to get that higher priority class and guarantee resources for that pod versus other pods.
Interesting.
Yeah, so it's a very complex network of things that come from just these 4 little lines of YAML.
So would general wisdom say that, like, for your applications that are central to the core functionality of your application, then your objective should be to have that top tier guaranteed quality of service, or is it not as cut and dry as that?
I mean, that would be a good general recommendation, right?
Okay.
I don't think anything's ever that simple in Kubernetes. So
I couldn't agree more.
Right. And because we're running multiple apps in a distributed system, like, you have to think about how it affects the apps around it. Right.
Yep.
So if you're only running one app, sure, give it a burstable QoS class. Don't give it any resource requests and limits, because you're basically just running one app across a bunch of nodes. But why are you running Kubernetes in that point, right? Like,
right. Yeah, there's always more around.
Yeah, so you got to think about how it affects the entire topology of the cluster and what it's running next to, right? So if it's mission critical and it's running next to like 12,000 other apps and they're not mission critical, definitely give it a guaranteed QoS class. Give all those other ones, small burstable ones, or let them be guaranteed, but give them less. There's lots of different ways to configure all of these settings to get sort of, I think of it as a topology. I think of all the apps running across all the nodes and try to think of, like, the different bins that they go into. I liked Justin Garrison's video about Carpenter when he did the different bin sizes and the different balls and kind of showed how that all went in. I think of it that way in a way.
Yep.
I don't know if you saw that one, but yeah.
Very cool. Very cool. So I guess where Goldilocks comes in is these magic numbers that you have to set to establish what your burstability is going to be, what your limits are, what your requests are, and like you described up front, I remember literally sitting in Datadog looking at months worth of statistics as well, and doing it over and over and over again for microservice after microservice. And it seems like by the time you get to the last microservice, a handful of weeks have passed, and the fingerprint of those services that you were looking at before have changed because developers never quit, and and memory always goes up. So I guess we're getting close to a point where I would like to sort of show a little bit of the Goldilocks user interface, because I just found it to be incredibly valuable to get those immediate, gut check values for what you could set for requests and limits. But before we sort of throw the screen over to you, so you can sort of show us with your mastery how the Goldilocks application works, I was hoping for our audience that we might be able to show them how to get Goldilocks installed on the Kubefirst platform real quick. Fred, if you want to throw my screen up.
I would do that, but even before that, let's welcome Halleck, another fan. Without him, we wouldn't have any live stream without Patrick, Alex, and everybody else joining the live stream. So thanks again for being here. And on that note, John, how do we install Goldilocks with the GitOps catalog?
Thank you for asking, Fred. So all our Kubefirst users are pretty familiar with this screen. This is the screen. Once you create your management control plane, you're left on this step 5, where we give you a password that you can use to log into your new Kubefirst management control plane. So you click this button and it asks you to log in. We use HashiCorp Vault as our OIDC provider. The default admin user, when we create it for you, is called KBot. And that password that I copied from the last screen, I'm going to paste right there. And then it lets you into Kubefirst. It drops you into the cluster management screen. We're going to ignore that for a little bit. Here in the applications, we have a handful of the core applications that are installed into your control plane available for you. But then we also have this GitOps catalog up here, where we have all the applications that are great for our users, but may not be great for literally every single user. So it's not a core component of our platform. It's just an application that can be added onto the platform at the conclusion of an install. So if we go to the Fairwinds docs on Goldilocks, they'll tell you that you basically need 2 prerequisites fulfilled in order to install Goldilocks. We're going to need a utility called Metric Server, and we're going to need another utility called the Vertical Pod Autoscaler. We've added both of those this week to the GitOps catalog. So the Metric Server will install first. That's required by the Vertical Pod Autoscaler, so be sure to install that first. And you can see with this installing, you might think, if you're unfamiliar with Kubefirst, that that's just doing like a Helm install directly to our cluster, but it's not. What it's actually doing is, if I go back to the GitOps
ClickOps, John.
I know. ClickOps is just an evil that doesn't need to exist anymore. So in the registry, there's a directory for each one of the clusters that are on your platform, and my management cluster is just called MGMT up here. And you can see that all of these were created a while ago, except for this one that was added just now. If we take a look at this Git commit, this is what happens when you click that button in the GitOps catalog. Is it basically just adds a Argo CD app of apps for the metric server into your GitOps registry. And then it's actually Argo CD's job to get that content into your Kubernetes cluster. So if we look at our registry right now, it has already picked up that change. So here we can see there's a metric server component that includes a metric server application, and it is up and running. Now, the next thing that we're going to have to install again through the GitOps catalog is the vertical pod autoscaler. We'll install that the same way. And in much the same way, if I were to go back to my, excuse me, to my management registry, here now we can see as of a second ago, we have a new vertical pod autoscaler, and that is in a second gonna get into the cluster. And we can see that's already running. In just a second, it's going to start hydrating an app. And it seems like it's going now. Let's take a look at its progress. And it's up and running. And then the very last thing that we're going to have to do is install Goldilocks. And thank goodness this is
the hero of the show.
Alphabetized, or else I'd never find these things anymore. So we'll install Goldilocks last, and we'll show you what the experience is when you do a default install of Goldilocks out of the gate. If I go back to my registry, actually, let me go here to my registry. We have Goldilocks installing in just a moment. 6, 5, 4, 3, 2, 1.
And you know, John, while it's installing, there's something really cool about the GitOps catalogs that if you're new to Kubefirst or GitOps catalog, you know what? It's on GitHub. It's a public repo. So we added a couple of applications that we think you would need to install on top of your cluster, because the Kubefirst, when you use Kubefirst to create your cluster, it's an opinionated platform, and we try to keep it as minimal as possible. So install all the tools that you think you need to be successful and production ready. But at the end of the day, you're probably going to need a lot more other tools. So you can use the GitOps catalog to do some what I call the real way of doing ClickOps, where it's heading the YAML file to your GitOps repo, and you're respecting the GitOps principle, but it's all there. So my point with that super long introduction to the catalog is that it's open source. So if two things, if you see applications missing, which is clear, it's missing. There are so many apps out there, but like if there's something that you need that is not in the catalog, feel free to do a pull request. It's pretty easy to do so. If you don't have time, you don't want to, you're not comfortable about doing the pull request about that, you want application headed to the catalog, please create an issue on the repo. And we have a little bit of backlog, but soon we're going to start to have like the application that people requested. So we had some like major refactoring of the catalogs. We had some tokens to make things more dynamic. So now that we reach a point with the catalog, we're like, okay, now we're going to start to have more applications. So let us know if there is things missing. We know you are able to install your application yourself, but it's just a nice, easier way to do so. So let's try to make the catalog as amazing as possible. And that's not going to be possible without your help.
Yep, 100%.
You saying you haven't pre-filled it with the entire CNCF landscape?
We're getting there. We're getting there.
Yeah.
I'm kidding. That thing is ridiculous.
I plan to do that right after the show.
Yeah.
So here we can see we have a new ingress for Goldilocks. And when you drop into Goldilocks, and this Kubefirst.tv is just the test domain that we're using. This is not a SaaS Kubefirst thing. It's just a demo domain that we use. So if you had your domain as your company.io or whatever, it would be goldilocks.yourcompany.io. So when you hop into Goldilocks for the first time ever, it's going to give you this message that, hey, I'm not monitoring anything. In order for Goldilocks to monitor something, you're going to have to decorate the namespace with a label so that we know to pick it up. Now, in a GitOps ecosystem, it's a little bit tricky to get that just right. You could just take this command and run it in a terminal, and that would suffice. But you have lost that detail about what's labeled in your GitOps repository. So as a GitOps practitioner, you probably don't want to do exactly that. So just to sort of show an example of a way that you can get that label, excuse me, into your namespace, let's take a look at the Argo CD namespace. Argo CD is one of those applications that does have sort of some more severe CPU requirement, memory requirement. Maybe it's one of the first applications that you want to get just right in terms of protecting for its quality of service. So let's take a look at what it looks like to get that label added onto Argo CD. Now, Argo CD also, unlike most of the products on the Kubefirst platform, they don't have a Helm chart for it. So we're using Customize in order to configure the Argo CD installation. So if you look at your management cluster and go to Components Argo CD, what you'll find is that there's a customization YAML that's looking at our Kubefirst manifest Git repository to know what the root configuration is for Argo CD. But there's a couple details that we want to decorate to make it a little bit different on this instance than what we have in our upstream at Kubefirst. So, and one of the things that we're going to want to change is this namespace here. We're going to want to add a namespace that says, hey, we want a namespace that's called Argo CD, but this right here is the important detail. You can see that what they're advising us to do in Goldilocks is to add Goldilocks Fairwinds com enabled equals true. That's what we're doing right in this line here, is adding Goldilocks Fairwind enabled equals true becomes :true when you're talking about in raw YAML. And basically the only thing that we're going to have to do to incorporate that in our particular instance is we're not going to add that as a resource because it's already in our upstream. So we're going to strategically merge that namespace YAML. And when I commit this to the main branch, usually you would want to have this pull requested. Don't fight me today, Fred. Don't fight me today. And in just a moment, or I can expedite that by hitting the refresh button. Let me go to Argo CD first, though. Argo CD. And when I hit refresh here, it would refresh automatically within the next 3 minutes. This is going to pick up that there's a change that needs to happen. That change is going to be the addition of a Argo CD namespace right here. That namespace is going to be decorated with a label right here for Goldilocks to pick it up. And as a result, and I'm going to give this like 5 Mississippi, 4, 3, 2, 1. It's probably ready now. When I refresh this page, now we can see that there's a namespace that Goldilocks has picked up that has some resources that it has some opinions about. Fantastic. So when we click this, this is basically where my knowledge drops off the page a little bit, and I would love to move the demo over to your space, Andy. But in just a second here, you can see that it's coming up with, and in fact, I think I'm being impatient again. It does take about like 30 seconds or so for it to hydrate with all the metric server information. But in any event, Andy, at this point, if you want to take the demo over, it's your show to show us how Goldilocks works exactly.
Happy to.
Thank you.
So I also actually installed Goldilocks with Argo CD in my cluster. So this is like a perfect handoff, which
Wonderful.
I'm sure never happens. But one difference about how I've installed Goldilocks here versus how you would get it like you did from just a clean install is the addition of a couple of flags. And I like these flags because they make it so that I don't have to go label all my namespaces. So if you really just want to run Goldilocks everywhere in your
Andy,
cluster.
Yes. Sorry, I'm so sorry. Yeah, exactly. What I was going to ask you read my mind. Wonderful. Sorry about that.
I usually remember to do that up front, but all right. So anyway, both the controller and the dashboard, there's 2 major components to Goldilocks. There's the controller that goes and creates all the VPAs, manages them, keeps them up to date. And then there's the dashboard, which we will talk about in a second that we just saw. But both of them accept this on by default equals true flag. And so if you add that, it will automatically create VPAs for every single namespace in your cluster. You can see I've got a few different ones here in this cluster. So you don't have to go manage all the labels and annotations on your namespaces if you don't want to. You can just pass that on by default flag.
Neat.
So definitely a useful thing to know if you just want to get it running across your entire cluster. Now, as I was setting this demo up, I demo a lot of different stuff all the time. So I have this cluster running, and I don't have any memory requests or limits set in this cluster whatsoever. And there's a reason for that, because I am actually working on automatic right sizing using VPA and a couple other things. And so you're going to see a lot of not sets in this.
Yep.
Don't do that. But because we're looking at the deployment that created these pods, these are not set. They're actually being managed automatically. A little bit out of scope for Goldilocks, but the dashboard will show you for every single container in each of the workloads that manages pods. And this actually could apply to other controllers that manage pods. It doesn't necessarily have to be deployments or stateful sets. We look for all the pods, and then we walk up the owner ref for each thing to get to the top level controller of that pod. And so if you're using say the Prometheus operator, which controls Prometheus's, right, as its object, those create pods underneath. I think we should see in the Prometheus namespace a container owned by a Prometheus. Maybe not. Anyway, it's supposed to work with all controllers. But what we see on the dashboard here is the VPA recommendation in graphical form. So we see a recommendation for guaranteed QoS, which is usually what I look at. And it says this pod should be set to 100 millicores and 100 megabytes of memory. And so really simple dashboard. We go here, we see all of our namespace, we click into the namespace we care about. We go to the workload that we're looking for. And here we have YAML recommendations that we can copy paste if we want, and put those on our deployment and control that going forward. So really the dashboard is intentionally very simple. There are some enhancements we're working on to show you whether you have an HPA for this workload. We also have the ability to add cost information based on just a static instance type. So if you run all M4 larges, you could put that information in. You have to get a token to hook that up to our backend so that we can fetch that information about cost for you. And I have that disabled in this cluster at the moment because it does get a little noisy. But a couple different features there, but intentionally very simple.
Very cool. And so these values that it's proposing as a good starting point set of values, how long should we expect to have to sort of bake in Goldilocks and run our workloads in order for those to have reasonably valid values for us?
That's a great question, and that's entirely based on the VPA. So we're getting, like I said, the recommendations from the VPA. So if I look for VPA objects, we'll see Goldilocks dash whatever the controller name was with the recommendations. Now, the VPA project recommends 8 days of data before you get really good recommendations. And actually, you'll see, if you go look through the issues in Goldilocks, there's a couple of bugs reported, which aren't actually bugs. But when you first install it, if you had recommendations on your dashboard that you showed, you might have seen some very odd numbers. I've seen terabytes of memory recommended because
interesting.
The initial out of the gate recommendation from VPA can be very errant if you're not hooking it up. The other thing to know about VPA is that by default, it ships with a what they call a checkpoint backend. Basically, they use a CRD in the cluster to store checkpoints over time. But what you can actually do is connect VPA to Prometheus. So if we go look at I think mine may be a little too zoomed in here. If we look at our VPA recommender deployment, and we go look at the flags that we have defined on here, this is a bad demo. Sorry. That's something else I was working on. But there are Prometheus flags that you can use to connect VPA to Prometheus. So you tell the VPA recommender, here's where my Prometheus instance is. I have this Prometheus here configured to hold 8 days of data. And so it gives me good recommendations out of the gate because that Prometheus already has that 8 days of data that I can look back at.
Gotcha.
What you saw there, we're actually working on connecting VPA to our insights platform backend where we store metrics for you. This is our commercial product of Fairwinds. And we're going to be working on automatically applying those recommendations from insights to your pods using VPA. So,
neat.
That's an upcoming feature in our commercial product that we'll be adding.
Very cool. Very cool. So, so in summary, I'm taken away to give it a little bit of time, potentially 8 days, for it to really get a feel for your workloads, how much memory CPU they use under normal circumstances. I imagine, let me ask you this. Do you have a recommendation? Like if I were going through this operation and I just wanted to get my requests and limits correct for every single application in my cluster, I would be inclined to start with production. What are my production payloads? What do they look like? And obviously you get some good load because it's production of real workload use in production. But in lower level environments, pre-production, a dev stage prod or a dev and stage environment, for example, maybe you don't get those same workload activities. Do you have a recommendation for us in terms of like, should we take the production values and apply them to the lower level environments, or should we be tuning each environment to its own sort of workload requirement? Like, how do you think about that?
That's a great question, really great question, and I think a very common problem that folks have. What we do is our non-production environments, all except for one, have specific resource requests and limits for that environment. And they're intentionally very low because we're trying to save costs. We actually run a copy of our product on our staging environment for every feature branch that we create. So we have a lot of different copies running at any given time. And if we ran those at full production specs, we'd be spending an obscene amount of money on no load, right?
Right.
We do have one environment and it's all in the same cluster. We have some dev environments, and then we have one load test environment where we run a load test against it every night automatically. And so that allows us to see some numbers for what production might look like. And that environment looks exactly like production. And so we get to load test against the production values. But it depends on how you're doing your testing, right? Like if you load test in your non-production environment, you probably want production level values there. But if you don't load test against it and it's just like one developer clicking buttons in your app, you probably don't need production level values there.
Roger that.
So
that's super helpful.
Yeah, you did touch on one really important thing, though, is that Goldilocks in its default configuration is very safe to run in a production environment because by default, we put VPAs in off mode. And so you can run it in your production environment, get these recommendations. It should be very non-disruptive to that environment. And so you can get those production values that you want.
Very cool. Very cool.
Now, do you want to hear the secret unknown feature of Goldilocks that barely anybody knows about?
There's nothing I like better than sharing secrets on live streams.
All right. So like I said, we put all of our VPAs into off mode by default in order to be non-disruptive. But if you want to change that, there are a couple additional annotations that we support that allow you to turn the VPA into auto mode. You were using labels for Goldilocks enabled. Annotations also work. And so we're actually slowly over the last couple of years moving towards annotations. But we have a couple other hidden annotations. So they're very lightly documented in the docs. But goldilocks.fairwinds.com/VPA update mode auto will turn the VPA into auto mode. And the VPA resource policy will allow you to fine tune that automatic behavior. So this is basically saying for every single container in this namespace, we're allowing a max of 4 CPUs and 6 gigabytes of memory. Now, and then we're also saying the minimum number of replicas that for the VPA to evict this pod in order to apply these recommendations is just 1. By default, it's 2 so that it's not evicting your singleton pods, which is nice of them to put in by default. But I've set it to 1 here because I'm running singletons intentionally.
Right.
But you can use this to sort of fine tune. You can set minimum allowed, maximum allowed, and there's some other things that you can set here. So what this means is that this VPA is actually in automatic mode, and whenever on a cadence, if the recommendation from the VPA is significantly different from what the pod's resource requests and limits are, the VPA will actually go evict this pod, and then there's a mutating emission webhook that will apply those resource requests and limits to the new pod as it comes in. And so we're automatically applying the recommendations here to these specific pods where the VPA is in auto mode. And that's the direction we're heading in the future.
Yeah, that's really neat. That's really neat. So no, that's really neat. That is a really cool direction. That's basically gonna land you in a world where you're able to configure your cluster to react to the shifts that need to happen, and it can be responsible for its own tuning of those pod resource and limits. That's super freaking cool.
Yeah. So we've been running that in our staging clusters. The real key is where you're getting your recommendations, whether you trust them, right? Are they working for you? It can be a very risky thing to do, especially if you're not, prepared for it. So something to keep an eye on. And then one important note about running VPA in auto mode is if you're also running HPAs, I don't think I have any in this namespace, but if you're also running an HPA that is scaling on CPU or memory, you're going to get some weird results, because if you think about an HPA, right, that's a target of 80% of CPU request. Say my CPU request is 100 millicores. My HPA is set to 80% of that. So the way the HPA works, right, it scales up another pod as soon as we cross that 80% threshold, and it tries to keep our average at 80%. Well, that means that the recommendation for CPU for that pod will always be 80 millicores, assuming the HPA is doing its job.
Right.
And so HPA and VPA don't play nicely together if you're horizontally scaling on CPU or memory. And so stop horizontally scaling on CPU and memory, switch to some other metric, like one of the golden metrics, and scale horizontally on that. And then you get dynamic horizontal and vertical scaling at the same time for the workloads that support it. So
that's really interesting to call out. So for vertical auto scaling, allow the CPU to drive the height of your pods, and then when it comes to figuring out the right number of replicas for your pods to scale out, leverage something like response time, something in Datadog, something that you can hook into that is not CPU directed. Very, very good, helpful nugget right there. I would not have known to do that up front, so I appreciate that intel.
Yeah. So if you're using, if you have Prometheus and you want to easily get, like this particular HPA is scaling on Nginx controller requests for this UI. That's a metric that's available in Prometheus if you're running, the default configurations of Prometheus and Nginx Ingress. And then I used Keta to generate an HPA for this, because Keta is an awesome project as well. So I feel like I'm talking about everybody else's projects, but I don't know. I just love this stuff.
Welcome to Kubefirst. That's all we ever do.
That's what we do.
No, that's fantastic, Andy. So I feel like we covered everything that I know how to talk about with requests and limits for memory and CPU, plus probably 3 other topics that I wasn't even prepared that we were going to be able to cover. Is there any other nuggets, details, anything else you wanted to make sure to get on surface?
No, I think that's it. I mean, I have jokingly said to folks that I think I could boil the last 5 years of my career, 6 years down to set your resource requests and limits. But I still hold by that, because it, like you said, like we expanded into 5 other topics from there. Like, it touches everything. It affects how your cluster scales. and it is really core to how Kubernetes operates. And so that's why I've been so passionate about it for so many years. And I think people are starting to get it. Like, we've switched from, people not setting their resource request limits to trying to optimize their resource request limits. And then there were probably 4 different companies at KubeCon in November in Chicago talking about, automatically setting your resource request limits. And that's where we're headed next. But it's still about resource requests and limits all the way down. So
right on. Well, appreciate you coming on the show, and it's always nice to have a subject matter expert on some nuanced detail of Kubernetes that we're all staring at, and we all just kind of go like that and step around, and we'll get back to it tomorrow, except we never do. It's really nice to have you on the show to sort of break down how to think about requests and limits. Goldilocks is obviously a really great tool to be able to get those gut check configurations for how to set your limits and requests in your platforms. Obviously, we showed it's easy to add to the Kubefirst platform. So for all our users out there, if you've kind of been avoiding the CPU requests and limits topic conversation, go ahead, install the 2 prerequisite apps, and then install Goldilocks. Take a look at it. They give it a little bit of time to bake in. Give it about 8 days, maybe a little bit less if you're aggressive like we are. And and then I think that sets our audience up really well to be able to always set requests and limits. Andy said so. I believe it. Thank you for coming on the show and telling us why today. I appreciate it.
I agree. Yeah, thanks for being on the show. I learned so much. Like, that was a really great episode for me. So amazing. So thanks again. And folks, don't forget, we're going to be back in 2 weeks. I'm not going to be in the show, though. I'm going to be on the plane to Scale Conference. So you're going to be stuck with John alone, because I think Jared is off also that day. So
yes,
I want to apologize in advance about that. I'm not going to be there to like control John and being sure.
No, yeah, this is going to be the first ever episode of Kubefirst Unhinged. It's going to be just phenomenally poorly orchestrated, and I'm going to be both talking and trying to figure out who's talking to me from various social avenues that I don't even know how to log into yet. It's going to be great. Send all your comments. I won't be able to figure out how to reply to any of them, and you can just watch me sweat through a live stream. It'll be in 2 weeks. You got to be there. It's going to be the best one yet.
That's going to be an interesting topic, but because I'm like that, I'm not going to tell you yet what it is. You're going to see it probably next week. I'm going to start to do a little more promo about that show, but that's going to be something really interesting. So I'm a little bit sad I'm not going to be there, but it's for some other funds. I'm going to speak at Scale Conference and going to have some fun talking about Kubernetes and Argo CD. And with that said, Andy, John, do you know what's the difference between a delicious dinner and a slow computer?
A delicious dinner and a slow computer. I got nothing again for you, Fred. I got nothing.
So this one's going to be interesting for a French speaker like me. So one's a rack of lamb and the other's a lack of ram.
Thank you, Fred. Yes.
First.
Yes, indeed. So now that you've made us all blush, can we go home?
I think we go. I think it's done for us. So thanks, John. Always nice to live stream with you. Andy, thanks again for being on the show. And now I'm doing this live. I'm asking you, I would love to have you back at some point doing another episode, but this time to talk about Polaris. I think that's still going to be super interesting for the audience. Great piece of technology. And you're just doing a great job. So like obviously I want you back on the show. So you don't have to agree now, but I've done this live for a reason. So maybe.
Hey, way to put him on the spot. I like that.
Definitely come back and do Polaris later.
Oh,
for sure.
that's okay.
Yeah.
That's
Happy
okay.
to
I
do
like
it.
that.
Yeah.
So yeah, sorry, I'm not a nice person.
But I'm gonna have to bring Robert with me because he sort of maintains a lot of Polaris now. So
It's a deal.
You might have
We-
two of us.
More the merrier.
That's right. We accept Roberts all the time.
Yeah. That's going to be amazing. So thanks everyone who joined live. If you're watching the recording, thanks also to you. And feel free to join our Slack community if you have any question or ask them, mostly on the YouTube video recording. And we're going to be more than happy to answer the question or ask Andy or someone on his team to answer you if it's something that we don't have the answer. So on that note, have a good rest of the day, everyone. It was a pleasure to be with you for that hour-ish. And have a good day.